Hello and welcome to the Trimble Access SDK tutorial series. My name is Nico Becker and I like to show you in this second tutorial some important debug settings as well as some settings inside Visual Studio. So let's get started. In the last tutorial we have essentially created our skeleton application. So at the moment we have an application that consists of 3 buttons. We can start that application, we can work with that application. What we have not looked at the moment are the settings that have been applied via the Visual Studio plugin. For that purpose, we go to the main project and go to Properties. First of all, many people think that because they're developing an application, they are creating an exe file in the end. So they ask, hey, I'm building my application, my build runs nicely, so I don't have any kind of build errors. Why don't I see an application in the end? The thing is that we actually don't generate an exe file, so we don't generate an application. We create a DLL that gets loaded by Trimble Access. So think of it that Trimble Access just looks what kind of applications are available, and it loads them and displays them for you. So you're not really creating an application, but you're extending an existing application via a DLL that gets loaded during the system start. So let's look at the settings. First of all, we have the General tab inside our Visual Studio project. If you look at how those names look like, these are all system macros. So during our installation, we place a bunch of system macros to your Windows operating system. These are all variables that get created during the creation of your project. So platform names, for example, Win32, you can change that to Windows Mobile, and these are all things that get reflected during your build process. You don't need to mess around with those, to be honest. Just for you to, it's important to notice that you're creating a DLL and not an exe file, and these are just the settings we use for our projects. More important are actually the debug settings. Because we are creating an application that is based on a DLL, so we're not starting the exe directly, but we are starting the survey exe, so general survey, with an additional command line parameter. In the last tutorial, so the first one, we've talked about the GUID, which is essentially the identifier of the application. So to start your application, you are starting survey exe, general survey, and you tell general survey to load a defined GUID, the GUID of your application. This is what you see here. We see here another macro. This macro essentially tells us where the survey exe for version 2.50 is located in our system. We will find these kind of macros all over the place. For example, we have a similar one for the API itself. Because of this we essentially include the installed API, so all the headers that come with the API. The same we will find in the linker settings. So if we look into the linker, we see DLL, so where our DLL is placed, as well as the API path we're including. If you swap your application from one Trimble Access SDK version to another, you will notice that those settings will change. So for example, it will change from 260 to 250 and vice versa. You should not change those settings manually. There are tools to do this. I won't show those tools now, but just as a, let's say, preview of what will come in the future. So if you look into our documentation, this is the offline documentation we ship with our installation guide. And this is placed in the installation folder of the SDK, and all tools that are shipping with the SDK are also explained here. And for updating versions, we use usually the Trimble SDK Update Manager, and we will talk about this in another series. I just want to mention it now because, as mentioned, it's the tool to use for updating your application. Now getting back. So, as mentioned, for developers, the most important things are usually the debug settings, and especially, this is like the default one. So if you just, build your application will run into tablet mode. This is fine for debugging and testing, of course, but if you want to design, let's say, UI for another platform like a TS3, TCU, and so on, you need to define or you need to develop a specific layout or specific UI for that. So sometimes it's handy if you know, for example, the platform you're looking for, just add the platform in question to your command line, apply the whole thing, start your emulator again, and you will see that the emulator switched to the resolution question. So in this case, this is the TS3 resolution, and we can now test our UI based on the TS3. The same, for example, could be done for this. Gets even smaller. Okay, so we know about this. Testing UI on the emulator is perfectly fine, that makes sense. Testing functionality on the emulator is sometimes not the best way to go. For example, if you work with external sensors, so like any kind of Bluetooth device or something else, you have to test on a TC3 sooner or later. That means you have to configure your debugger for using the C device. Our default template does not pre-configure the Windows Mobile debugger. That's a little bit tricky to explain, but to make a long story short, you can debug on your CE device pretty easily, but you have to do some manual things. First of all, you have to select the right platform. So for now, we go to CE. You might notice that you have now, the view has now changed. The deployment tab has been added. And the deployment should be more or less already correct. So I'm assuming we have installed the Windows Mobile 5 Pocket Framework that is required for developing applications that run on the TC2, TC3, and so on and so on. And the deployment settings are usually correct, so you don't have to change anything on this. These are just, let's say, links to the output folder where the application gets deployed to. What's usually wrong is the debugging folder. So you have to, essentially you can copy the settings from your Windows 32 project. Good practice is just to copy paste the command line, because this is the same as for Windows 32. The only downside is that you can't copy paste the remote executable. This is essentially the path where General Survey is located on your C device. So best thing is go to the deployment settings, copy paste this string here, so you only need the part program file General Survey, copy paste that, go to debugging, put it in here, and then expand it with SurveyExe. This is the default installation folder of SurveyExe plus your application GUID. If you apply these settings, connect your TC3 and deploy to the device, you can do this via a right mouse click and then deploy. You will see that if you debug your application, your TC3 will launch your application and you can debug on the TC3. As mentioned, this is important if you do like external communication stuff, or if you do some really hard math on the CE device, because this sometimes, let's say, behaves slightly different compared to Windows 32 because of how floating numbers are used, how the precision of floating numbers, to be precise. These kind of things can affect the whole thing. The last thing I would like to talk about are the build steps. Here we go, especially the post-build steps, where we are. So what you see here, another thing that often arises as a question is, okay, we've now answered, we don't create an exe file, we create a DLL that gets loaded by Trimble Access. What you also get often asked is, how do I install my application? Usually, the first statement is you have to switch your version to the release version, because only in the release version we launch the install scripts at the end. If you look at the whole thing here, there's actually quite a lot of things that are happening after a successful build. So assuming we're in the release mode, first we do a lot of file copies. So let's say we get all our things together and we do a little of cleanup. Then we launch our create resource DLL. This is another tool that ships with the SDK that is also explained in our documentation. And that creates essentially a resource DLL for you that gets used inside the Trimble Access launcher. So the Trimble Access launcher is not the same as Trimble Access General Survey. These are two independent tools essentially. And to have your own icon inside the Trimble Access launcher, you need that create resource DLL access, because that creates a DLL that then gets loaded by the launcher and so on and so on. After this process, so after we have our DLL as well as our, let's say, system integration DLL in place, we are running the install scripts. So these two scripts essentially package all our things and make them nice and easy to install. Last but not least, we rename our installation file to something more handy to use, so something with a version number, for example, and in the end we copy it to some common place so it's easy to find. Well, this is actually the build step in the release process. The build step for CE looks actually similar. It's a little bit less because we don't do that much copying, but the process is essentially the same. For debug, it's a little bit different because we don't do that much compared to release. The only thing that is important to know is that Trimble Access has essentially two places where it looks for applications or extensions. One place is the debug output folder. The other place is the program files folder. So you might know that if you install an application via the typical Windows way, it ends up in program files. The program files folder is write protected by the UAC, the user account control by Windows. So it's not that easy to change data inside program files. For that purpose, we have two stages or two areas where we place our files. The first one is the so-called updata folder. If you're familiar with Windows, you might know updata. You can just copy-paste that macro into your Explorer and you see where you end up. And that's the path we use for our plugins. Now, this is one location where Trimble Access looks for plugins. The other one is, of course, the program files folder. In debug mode, we always deploy to the updata folder because this one we can read and write all the time, so we don't have any kind of permission issues. Installations always install to program files. You might notice that if you run an install script that you always need admin rights because you installed program files. For that reason, we don't do this in this stage because this would require elevation every time we want to deploy or debug our application, which would be a little bit too much. Okay, what else is important? One last thing, we've talked about the TBD file recently. As mentioned, this file is essentially used for handling translations, and it maps strings to integers, or it's essentially a lookup table. The TBD file is created during our build process, so it has its own custom build process that gets triggered before the application gets built, or because the other DLLs get built. So if you see like an Xcode issue, like a warning, the Xcode does not exist, it's always a good thing to rebuild the complete solution instead of incremental build. Because only rebuild triggers the build of the translation database, essentially. I guess most people won't find this issue, but sometimes if you have a big application and you only do builds because it's faster compared to a rebuild, and you get these kind of errors, keep in mind either do a rebuild to get all Xcodes refreshed, or to right-click on the demo file and press compile, and it also gets built. The last thing I would like to talk about in this demo is versioning. So in the macros you have seen, where is it? We have version numbers inside. Like for example, we are including version 2.50, 2.60, etc. So we are always compiling against a version, a specific Trimble Access version. That means we always compile against a certain set of functions or interfaces. What does that mean? Usually our SDKs are always backwards compatible. This means that even if you compile, for example, against version 2.50, your application will still run with applications that use a higher SDK. So for example, 260, 270, and whatever comes next. This is because of the API structure that we have internally in place. To explain what I mean, so this is essentially how our API looks like. On the very right side, you see the SCAPI interface. That's essentially your application. You are including or referencing headers, that is our so-called outer interface. You might notice that when you change between, or when you switch between versions, for example, if you update your application from SDK 2.50, 2.60, or any other version, you might notice that although your application still runs, you can't compile it anymore. This is because the outer interface is broken. So the interface between your application and our outer interface. There, in this interface, it's possible that you will see changes, for example, because we had to add new hardware, or we just extend our features. So these kind of interface breaks are okay. The reason for that is that we have a second inner interface in place. This is the way we keep our backwards compatibility, and this is always constant. So the interface between the outer interface and the inner interface is constant, and actually pretty messy because of that. And the inner interface, of course, calls to survey core. So from an application developer point of view, it's only important to know if you compile an application against version 2.50, it will always run on general survey 2.50 and above. not below. And if you have source code that compiles against 2.50, it might be that it does not compile anymore if you go to 2.60, but this is only because the outer interface has changed. Your application will still be compatible if it was compiled with 2.50. That means if you have the DLL, it will just run. If you have to build it, the build might not work if you have changed your version number. That's the way we have, let's say, established, or we have created our backwards compatibility and how it's used. So that's all for now. We had a brief look at the settings and how our project is set up with regard to debugging, etc. We've seen how we can change the look and feel of our emulator, so how we can toggle between TC3, TCU, and of course the tablet. And we've also learned a little bit about the build steps, the custom build steps we're using, and that stuff. Okay, that's all for now. Thank you for watching.